is practice 4.2. We want to sketch these, including the asymptotes. So our vertical asymptote, remember we set the x plus 4 equal to 0, so we get x equals negative 4. The horizontal asymptote is, since they're equal exponents, so it's 1 over 1. Our x-intercept is when we set our y equal to 0. So we have 0 is equal to x minus 3 over x plus 4. Okay, to cross multiply, you have x minus 3 equals 0, therefore x equals 3. Okay, and the y-intercept is when we set the x equal to 0. So we'd have y is equal to negative 3/4. Okay, so we put this all together. Okay, we'd have it x equals negative 4. We have an asymptote at y equal 1. We have an horizontal asymptote. X-intercept is at 3. And y-intercept is at negative 3/4. You can kind of guess where it is or go to Desmos. Our graph's going to come up through like this and down like this. Number 36, to find our vertical asymptotes, we set the bottom two factors equal to 0, and we get x equals negative 2 and x equals negative 4. So at negative 2, there's an asymptote, and at negative 4. Okay, for the horizontal asymptote, okay, this would be an x squared equation, right? If I take x times x is x squared, which means it's bigger on the bottom, which means it's going to be at y equals 0. So we have an asymptote there. Okay, so the x-intercept, you basically just set the top equal to 0. You get x is equal to negative 1/2. So I have an x-intercept there. And the y-intercept is when my x is a 0. Okay, this would all this at the end here would be, when you multiply this out, x squared plus 6x plus 8, so it would be 1/8. Okay, so around there. Okay, so when you go to Desmos, or think about what it looks like, we're going to have a graph that looks like this. And this part here goes up through these 2 points that we just found, x and y intercepts. And this part here is just down through there. That's 36. Number 40, our vertical asymptote, set the bottom equal to 0. So x plus 1 equal to 0 and x minus 4 equal to 0. It's nice it's already factored. I get negative 1 and 4. So no vertical asymptote at negative 1 and at 4. Okay. The horizontal asymptote, set the, okay, so if I would multiply this out, this would be x squared minus 2x minus 15, right? And on the bottom, multiply that would be x squared minus 3x minus 4. So notice they have the same degree, so it's going to be at y is equal to 1 over 1, which is 1. Okay, and x-intercepts and y-intercepts. X-intercept was my y equal to 0, so that, remember that cancels out, so it's going to be at negative 3 and at 5 when I set these both equal to 0. So x-intercept is going to be at negative 3 and at 5. The y-intercept is when I set the x equal to 0, so these would all cancel out, so I'd have negative 15 over negative 4. Okay, so what's 15/4 would be almost 4, so it'd be up here somewhere. Okay, so my graph is going to look like this. Okay, number 44, for the vertical asymptote, set the denominator equal to 0. Factor it to be x plus 3, x minus 3. So you get intercepts at negative 3 and 3. Or not intercepts, but asymptotes, -3 and 3. Okay, horizontal asymptotes. Okay, they're both the same, so it'd be 16 over 1. So up here, it's, say this is at 16 right here. Okay, x-intercept happens when my y is a 0. So it's when 16x squared minus 9 equal to 0. I'm going to use the square root method. Add the 9 over, divide, and then take the square root. So it's plus or minus 3/4. So go up here at 3/4. And the y-intercept happens when the x is a 0, so put a 0 in there, we have -9 over -9, which is at 1. I'm sorry, 1, and then negative plus and minus 3/4 for that one. Okay. All right, and then your graph will look something like this. That's number 44. Number 48. Our vertical asymptotes, 2x plus 4 equal to 0. So subtract the 4 divided by 2, you get -2. And the horizontal asymptote, when it's bigger on the bottom, right? This is x to the first, there's 0 x's up there. It's at y equals 0. Okay, x-intercept happens when the y is a 0. So at -5, hold on, no, because if I set this equal to 0, so if I solve this, right, I get 0 is equal to -5, which doesn't make any sense, right? There's no x to solve for. Which also makes sense because there's an asymptote there, so there shouldn't be an x-intercept. Okay, so none, no x-intercept. Y-intercept happens when the x is a 0, put a 0 in here, be at y is equal to -5/4. So down here somewhere, okay? So our graph will look like this. 52. Set the bottom equal to 0, you get x equals -2 and x equals 3. For the horizontal asymptote, okay, this would be an x squared. That would also be, okay, so if I multiply that, it'd be x squared, right? Multiply x plus 1 times x plus 1, it'd also be 1x squared. So 1 over 1 is at 1. X-intercept happens when this is 0, and cross multiply just x plus 1, so x equals -1. And the y-intercept happens when the x is a 0. So if you think about this, this would be x squared plus 2x plus 1. This would be x squared minus x minus 6, so it would be -1/6. Okay, so this graph goes like this. Kind of a double 0 there, right, at -1. And comes back down. And then if that's there, that means this is up here and up here. Number 56, our vertical asymptote. Set that equal to 0, you get x equals 4. Okay, our horizontal asymptote, this is one we haven't worked a whole lot with. When it's bigger on the top, right, higher degree on the top, we have to divide and see what happens here. Don't forget that 0 in there. Actually, you could use long division too, either way. Would be 2x. Would be 2x squared minus 8x. And draw the line, change your signs to subtract. So you get 8x plus 3. What times x is 8x? 8. 8x minus 32. Draw a line, change your signs. The reminder doesn't matter here, so 2x plus 8. So if I go up here to 8, go up 2 over 1, right? There's my other asymptote. Okay. And the graph looks like this. Oh, let's find the x and y intercept. X-intercept when the y is 0, so that times 0 is 0. It'd be where 2x squared plus 3 is equal to 0. That's going to be an imaginary, so there are no x-intercepts. Y-intercept is at negative 3/4. So we know it's going to come up and hit here like this. Okay, that's 56. Okay, number 60 is kind of a unique one. Okay, we'll go with the vertical asymptote first. Set the bottom equal to 0. You know the x, negative 4 here. Okay, but let's see what happens here. Okay, well, higher degree is up top, so we have to divide it, right? And actually, let's just do this right away. If I recognize this, hopefully I can recognize this as x minus 4 and x plus 4 over x plus 4. And if I divide those, I get x minus 4. That's where my horizontal asymptote is, right? Remember, if it's larger on the top, you have to divide these. So you could use long division or synthetic division. You'll get the same thing, but notice they just cancel out. So our oblique asymptote is at x minus 4. So start at negative 4, go up 1 over 1. Okay. Now, this is actually the whole equation. It's not an asymptote. So notice those cancel out. We're just left with x minus 4. But what happens down here? I should have drawn that a little bit either. But down here, remember how there's an open circle right here? Because I know my x can't equal negative 4 down here. Okay? So the graph would look like this down at that point. Okay, the open circle there at negative 4. Yeah, the y-intercept, there's the negative 4, and the x-intercept is at positive 4. 64 is another unique one, because I just kind of recognize this. You can work it out too. But you know the top there is x plus 2 and x minus 2. And the bottom would factor to be x plus 2 and x plus 1. Notice those two would cancel. I'd just be left with x minus 2 over x plus 1. So that's essentially what we're graphing here. Let's go through it here. Okay, so our vertical asymptotes at the bottom equal to 0. And we said it was x plus 2 and x plus 1. So my asymptotes are at negative 2 and negative 1. Okay. So negative 1, well, might be an asymptote, might not be an asymptote, right? It might just be a hole. And actually at negative 2 it is just a hole, right? Okay, because those cancel out there. The horizontal asymptote happens when I divide them. So if I divide these two, I know I get x minus 2 over x plus 1. So that's basically the graph we're using there. And to graph that, so we know there's an asymptote here. Okay, and actually it's x squared over x squared, right? So it'd just be at 1. Okay, so our graph looks like this. But right here at negative 2, I know there's a open circle right there because there's a hole. There's no asymptote there, just a hole because it cancels out. Okay, actually I didn't do the x-intercept is when the y is 0, set this equal to 0, you get 2 and negative 2. Okay, so that's out there at 2. And the y-intercept is at negative 4 over 2 is negative 2. So that'd be down there at negative 2. Okay. We didn't have I said 2 and negative 2 here, right? But one of them canceled out, right, when we did this. So it's just the 2. Okay, 68. This will be a good one. Okay, so for our vertical asymptote, set the bottom equal to 0. Okay, so I'm going to use factoring, x squared and x squared. Okay, 108 and 24. Okay, that took me a little bit to figure that one out, but it comes up to be negative 18 and negative 6. Multiplies to give you this and adds together to give you that. Okay, so we got to solve these. So add that over and take the square root, and the square root of 18 is like 2.24-ish. Okay, remember the plus or minus. So 2.24, we have one right here, and we have the negative of it. 2.24 would be about there. Okay, solve the other one. You got x squared is equal to 6, and plus or minus the square root of 6. Square root of 6 is 2.44. I'm sorry, this isn't 2 point, that'd be 4.24. I got that wrong. So we'll take these two as the 2.4, and then 4 point there, and there. Okay, so we got our asymptotes there. Okay, the horizontal asymptotes, they're equal degrees, so 1 over 1, so y equals 1. So horizontal asymptote here. Okay, x-intercepts. Basically, you have to factor the top there. It'd be x squared minus 4 and x squared minus 1. So this would be plus or minus 2. This would be plus or minus 1. Okay, so we have x-intercepts at plus or minus 2, plus or minus 1. X-intercepts right there. And the y-intercept happens when that's divided by that, which is 4 over 108, which is, I don't know, 0.03, so it'll be like way right there. Oh, positive though. Okay, so our thing looks like this. Okay, it happens there in the middle, and then this thing happens something like this, and then this thing over here happens like this. Okay, kind of a weird looking graph. Glad we have Desmos to kind of help us with that too. But make sure you think through these things here and make sure you understand those as well. Number 75 gives us this graph and tells us to graph it on a calculator, so use Desmos. It gives us the graph that looks like this, our x-intercepts. If we click on them in Desmos, we get at -2 and at +2. So 2 and -2, and then this one right here is -2/3. So -0.666666. Okay, y-intercept happens down here at -2. Why is there no vertical asymptote? Okay, no vertical asymptote because to find vertical asymptotes, I set this equal to 0, right? X squared plus x plus 4 equal to 0. So if I set this equal to 0 and try and solve this, it gives me imaginary solutions. Okay, so that's why there are no vertical asymptotes in there. Okay, oblique asymptote happens when I divide these, so I have to divide them. Okay, 3x times this stuff here gives me 3x to the third plus 3x squared plus 12x. Okay, and I'm going to draw the line and change the signs here. So those cancel. That gives me -x squared. Those cancel, -8. And what times x squared is -x squared? -1. So if I multiply -1 times all of that, it'd be -x squared minus x minus 4. Draw the line, change your signs there. Those cancel. I have x minus 4. Okay, but you remember the remainder doesn't matter here. So our oblique asymptote will happen at y is equal to 3x minus 1. Okay, so that's what this right here, if I go -1, this right here, okay, this comes up like this comes out like this. Okay, the domain, okay, will be all real numbers. Okay, because there are no numbers that will make this equal to 0. And our range, this will keep going down, that'll keep going up, so that will also be all real numbers.